So in the last video, we were confronted with a lot of different rules, and we're going to use and practice these rules on lots of different types of functions. But the biggest tip is to convert terms to exponential form. That means any radicals you want to convert to exponential form. And if we have, for instance, 1 over x, we want to convert that to exponential form. So the square root of x, we want to convert to x to the 1/2. 1 over x, we want to convert to x to the -1. And lots of different examples like this. So our first example is we are given f of x is 6 times the square root of x. And we are asked to find what the derivative is. It might be worded in lots of different ways. Differentiate the following, various things like that. So when we're confronted with this, we are going to use two rules that we talked about. One is the constant multiple rule, the fact that it's 6 times the square root of x. And then we're going to use the power rule. We're going to convert square root of x to that, and we're going to use the power rule on that. So when we do this, we need to rewrite f of x first as 6x to the 1/2. And in chapter 1, we might want to go back and practice some of those, the section on power functions, to practice some of these rules or exponential form in general. So now we can use the fact that when we take the derivative, we have a 6 times this, and it's going to be 6 times the derivative of this using the constant multiple rule. And using the power rule, we bring the exponent down. And then we're going to reduce the exponent by 1. So I'm going to write it, because it might take a little bit of practice to get these exponents correct. I see a lot of mistakes on the arithmetic on those. So when we simplify, 6 times 1/2 becomes 3, and this becomes x to the -1/2. And if this were in the back of the book or in some other places, you might see this as 3 over the square root of x. They might change it back to negative exponents are on the it's on the bottom, and an exponent of 1/2 is the same as square root. Either of these for me would be acceptable, but sometimes it might be easier to work with that one. The next example, we're going to look at q to the 13 minus 5 over cubed plus 7. And we're asked to find what the marginal cost function looks like. So we're asked to find what the marginal cost looks like. Remember, that's also asking what the derivative of c looks like. So when we do this, we want to convert again to exponential form. So we want our cost function to look like q to the 13, q cubed, oh, that's a mouthful, q cubed on the bottom becomes minus 5q to the -3 plus 7. And now we're going to use several of the rules. We're adding and subtracting, and then we have a constant. We're going to get the derivative. Using the power rule, we're going to get 13q to the 12th power. And then careful, we're going to have minus 5 times -3. So I'll write that. Q, and then I'm going to write all of this out, maybe more than you would, but the more you practice it, the less you would have to write out. But at first, it might be good to practice that if you find yourself making a lot of mistakes. And then this is just a constant, plus 7, and the derivative of that is 0. So to rewrite, this becomes plus 15 q to the negative 4. And that is our answer.